Assalamualaikum and hi. Just a recall, previously we have learned about chapter 5, which is integration. So you have learned what is integration itself, the rules of integration, how to integrate exponent, how to integrate when you have a function, and so on. So today we're gonna learn about chapter 6, which is techniques of integration and improper integrals. So let's see. This is the outline of chapter 6. So we have chapters, three main subtopics. The first one is techniques of integration using substitution. The second one is using by-part technique. And the third one is integration of trigonometric functions. So for today, I'm gonna explain about this only these two parts, and the trigonometric function I'm going to explain next week. So for the first one, integration of substitution technique. So what is substitution technique? Let's see. We have given we are given integration of function f gx dot g prime x dx, which is also equal to integration of fu du. So basically what we have here is you have two functions, which is gx itself and the g prime x, after you differentiate it. So in here, we're going to substitute the gx into the f function. So it's no longer gx. It will become a new function, which is fu du. So we're going to have equation like this: capital of F, U plus C. What does it mean by capital F is after you integrate, you're going to have the uh, output after you integrate, right? So this is it. Capital F U plus C. So the U previously is GX, the one you have substitute with U. So GX is actually equal to U. So you're going to put it back the GX into the equation. So basically these are the steps involved in the substitution method. The first one, you're going to substitute U with GX. And then you're going to choose your du, or you differentiate U with respect to x. So you're going to have du over dx. But we only need the du term. So the dx over dx, you're going to bring it on this side, on the right hand side, in order for you to obtain the integral of fu du. Then the second step is going to integrate fu with respect to u after we obtain the u, after we substitute the u previously. Then you integrate the fu. And the last step is you're going to replace back the u by gx in the result. So at the end of your answer, you're not going to use u. You have to substitute back the x function. Okay, I'm sorry. I think you are not very clear about this, since this is only the methods. So we're going to see the example. This is the first example. Now you have to find the integration of 3x plus 2 to the power of 4 dx. So we're going to find this. So now, as we can see that it is similar to x to the power of integration of x to the power of 4 dx, where the function in here, you have 3x plus 2. We want to simplify it. So we assume it as x, like this. Okay, so except that it is replaced by a linear function. Dia kata dekat sini, function yang ada kita kena bagi dekat sini, actually you boleh simplify. Not necessarily you use 3x plus 2, you can use just one thing. Contohnya x ataupun u. So in this case, we substitute 3x plus 2 equal to u macam ni. So you're going to let u equal to 3x plus 2. Yang panjang-panjang ni, we let it as u. Satu term saja. So now you're going to integrate u to the power of 4 dx. So we get du over dx. Right? Du over dx. Where do you get du over dx? Okay, the du over dx is you get from here. See, you differentiate u with respect to x. Now you have 3x plus 2. So we want to differentiate u with respect to x. We differentiate this side. So differentiate 3x plus 2, you will get only 3. That's why you get 3 in here. Okay, so the du over dx equal to 3. But now, since we have this equation or this form, we don't want the du, we only want the dx. So dx over here, you're going to bring this dx in this side and the 3 in this side. So you have this one, dx equal to du over 3. Why do I do this? It's because you're going to substitute this dx into this dx. Okay. Sorry, let me... Okay. The dx over here, you're going to substitute it with this. That's why we want to find dx. So you already have your u is actually this one, this part 3x plus 2 and to the power of 4, and dx is this, the green box. So you're going to have integration of u to the power of 4 dx equal to 1 over 3. Why is it 1 over 3? Because this one, 1 over 3 integration of u to the power of 4 du. So we're going to write back the dx over here is actually equal to du over 3, right? That's why you have 1 over 3, or actually equal to 1, sorry, how do I erase this? Okay, so you're going to have du 1 over 3 du, right? So this is what you have, 1 over 3, and then you have du. This is actually from the dx, the one you get from the first one. Yeah. So the integration u4 is what we have over here. You just substitute the dx with the one you solved previously. Okay, so now you can integrate. You have 1 over 3. 1 over 3 is a constant, that's why we put it outside. Then you're going to integrate u to the power of 4 du. So you integrate u to the power of 4, you get u to the power of 5. Divide by 5. Remember, this is basic rules of integration. We learned it last week. And then don't forget to put a plus c, the constant. Okay, so you just expand this one, just multiply it, then you get u to the power of 5 over 15 plus c. So we can say that the one we have previously, remember, this one is in term of u. You need to change it back into x. So what is your u just now? Your u is this one, 3x plus 2. So you're going to substitute it back with 3x plus 2 to the power of 5 over 15 plus c. So this is the final answer. So the final answer must be in x term. So next example, find integration of 4x plus 3 multiplied with another function which is 2x squared plus 3x minus 5 to the power of 3 dx. So you have two functions over here, the first one and the second one. So what we're going to do is we're going to choose the longest function or the longest term, you're going to substitute it with u. So compared to this is the longest one, right? So you're going to substitute this with u. Okay? So let u equal to 2x squared plus 3x minus 5, where when you differentiate it du with respect to x, from here we differentiate it du over dx. So you get differentiate 2x squared, you get 4x. Differentiate 3x, you get 3. That's why you have over here. Okay? So then again, you're going to rearrange the dx because you only want the dx term over here. Remember, you have dx over here. So this dx, you're going to change it with du, the u term. That's why after you get this, you're going to susun semula, rearrange, bring this dx into your right hand side, and then this whole thing over here, you're going to bring it over the left hand side. So it become over 4x plus 3. So this, you're going to have this. dx is actually equal to 1 over 4x plus 3 du. So now you can substitute this in the green box over here with this. You already have the dx, right? Okay, you already have this one. So now we're going to solve it. Integration of 4x plus 3. The one over here, the longest one, is already become u to the power of 3, because we have power of 3 over here. And then we have to substitute the dx. The dx is no longer dx, it become 1 over 4x plus 3 du over here. It's become this one. Okay? So what we have over here, you have u cubed, and it's a bit messy, but don't worry. You see over here 4x plus 3. This one also 4x plus 3. We can cancel. We can cancel it. So boleh potong, and then the only thing left is u to the power of 3. U cubed times 1, you get u cubed. So now you only need to integrate u cubed du with respect to u. So macam biasa, kita integrate u to the power of 3, you get 1 over 4. Remember, kalau integration, you need to plus 1. So you have u to the power of 4, and then we divide it with the new power, 1 over 4 plus c. So again, this is not the final answer. You have u over here. You need to substitute the u with the x just now. Don't forget to substitute it back with this term. So you're going to have like this. 1 over 4, or divide by 4, it's similar. U, just write it back, 2x squared plus 3x minus 5 to the power of 4 plus c. So this is the final answer. Okay, example 3. Find the integration of 2x over x squared minus 3 dx. Okay, let's see. Which one is the longest? This one, right? X squared minus 3. So the longest one we're going to substitute with u. So u become x squared minus 3. Now from here you're going to find the du over dx. You're going to differentiate it with respect to x. So we differentiate x squared, you get 2x. We differentiate 3, you get nothing. So this is it, 2x. So now again you have to rearrange it, since we need to find the dx to substitute with what. So you rearrange, susun semula, then you will get the dx is actually du over 2x. This dx, you bring it on this side. Okay, so this is actually this. You can substitute it with this, du over 2x. Okay, now you already have u, you already have your dx, right? Okay, so you're going to have 2x, we just write it back, 2x over u, this is u, dx. So dx is already this one, du over dx. Okay, don't get panic when you see this thing messy over here. you can slowly potong dia. Because 2x over 2x you can cancel out. So the only thing left is integration of 1 over u du. So remember previously we have learned how to integrate when you have a fraction, ada pecahan. So 1 over you will get integration of 1 over you will get ln u plus c. And again, don't forget to substitute back your u. What is your u? This one, x squared minus 3. So you're going to substitute it back with x squared minus 3. So this is the final answer. And example 4. Okay, again, we're going to choose which one is the longest term, which one is the longest function. So this one is the longest. So this one become your u. Okay, so you have u, we let u equal to x cubed minus 2x squared plus 1. And again, you're going to find the du over dx. You differentiate u with respect to x. So slowly, differentiate x cubed, you get 3x squared. Differentiate 2x squared, you get 4x. Differentiate 1, you get nothing. So you have this. And again, we need this dx over here. We don't need du over dx, we just need dx. So you need to rearrange. Susun semula. So you bring this dx on this side. This whole thing over here, you're going to bring it over the du. So it become like this. Du over 3x squared minus 4x equal to dx. Now you have dx and this you have dx. So this one is you can substitute it later. Okay, then we just write it back. This one, this part, integration of 3x squared minus 4x over u, since this one become u already, over u, times with dx. What is your dx? Your dx is over here. Du over 3x squared minus 4x. Again, slowly you check. This one can be cancelled out. Kita boleh potong. And the only thing left is integration of 1 over u du. Ini saja yang tinggal, integration of 1 over u du. And remember, integration of 1 over, you will get ln. Apa sahaja yang 1 per ataupun pecahan, you will get ln bila you integrate. So you have ln u plus c. Okay? And the u, just now, you're going to substitute it back with the x term over here. So it become ln x cubed minus 2x squared plus 1 plus c. That's it. Okay, now as we can see from example 3 and 4, the one with the pecahan, the fraction, we find that when you integrate this part 2x over x squared minus 3 dx, you get ln this thing. You get the ln of the denominator itself. Okay, dia akan dapat balik yang bawah ni. Sama juga. And this one, ini adalah example 3. This is example 3. This is example 4. Okay. We done it before. So, dia akan dapat balik, bila you integrate, you akan dapat balik ln of this thing, the denominator, plus c. Okay. Thus, we can conclude that, or we can write it back as integration of f prime x over fxx actually equal to ln fx plus c. The fx here is from the denominator ataupun penyebut pecahan tu. Okay. So these are some of the exercise. Please try it on your own so you can check back the answer over here.